On the 14th of December 1984, a bizarre vehicle rolled out of NASA's hangars. The unusual design, dubbed the X-29, incorporated forward-swept wings. But why? To answer this, we need to look at why planes' wings are angled in the first place and why older ones weren't. But before we go on, remember to hit the like button and subscribe to my channel. The way airplanes generate lift is by having higher pressure on the lower end of the wing than the higher end. The high pressure pushes the plane upward, while the low pressure pulls it up. Meanwhile, from a top view, the wind flows over the wings from the front to the back of the plane. The passing wind is also known as the chordwise flow. The chord is an imaginary line which runs from the leading edge to the trailing edge of the wing. And here, there's a huge problem. Since the lower pressure air on the top of the wing travels faster than the plane itself, it can cause shock waves far before the plane reaches supersonic speeds. This can lead to a dangerous thing called flow separation, where your plane can lose lift. And usually, when a plane doesn't generate any more lift, it tends to fall right back down to the ground. So in the 1940s, German engineers tried to make a plane with swept wings. But how does it work? With a plane with swept wings, the sweep is usually at about 20 degrees. So, the chordwise flow, or the orange line, is offset at a 20-degree angle relative to the wind. And there's also a new component called the spanwise flow, or the green line, which spans between the chordwise flow and the wind. This is especially useful for jet planes like the F-14 Tomcat, because when they're going faster, they're generating more than enough lift. So the F-14 was designed to sweep its wings backwards as much as 60 degrees. This would convert the energy that would cause a shockwave on a straight-winged plane into spanwise flow. But now, there's a big problem. When the spanwise flow eventually reaches the tip of the wing, it interferes with the wind that comes from the front. This can cause a lot of vortices. Therefore, the irregular wind strength can lead to a loss of roll control. And this is where the X-29 comes in. The experimental aircraft had forward-swept wings, not only to look really cool, but also to reverse the direction of the spanwise flow so it hit the root of the wing instead of the tip. Then, a detailed computer study proved that it would be 20% more efficient than the same plane with backward swept wings. But you know, just looking at it, that something doesn't quite look right. In fact, there were two problems facing the X-29. One was that the wings flexed too much, although that wasn't a worry after advanced carbon composite was available. Another issue was that the X-29 was incredibly unstable. It even required 3 flight computers to assist the pilot in controlling it. And even with those, it was still very hard to control the vehicle. This meant that it couldn't do high agility maneuvers like a fighter jet. This is the first video of my atmosphere and aviation playlist, where I explain how far the exosphere goes, or the incredible engineering of the NASA AS-1 with irregular wings. Once again, remember to like and subscribe, and also to comment and share. This has been Head for Science, and I'll see you in another video.